We're going to do question number 15. This is on Newton's laws, Newton's first law about equilibrium. And it refers to this picture. And the first thing I do when I do the problem is to draw the sketch. And now let's read the problem. It says a 5 kilogram block. So the mass of this thing is 5 kilograms. It's at rest, velocity initial equals 0. Frictionless surface is acted upon by forces F1 of 5.5 newtons. So F1 is 5.5 newtons. And F2, which is 3.5 newtons. 3.5 newtons. You'll notice that the first one's being acted on by some kind of a handle, the second one by a rope. In a chapter, we're going to call this squeezing force compression, and this pulling force on the rope as tension. But we'll get to that. What additional horizontal force, what force in the x direction will keep the block at rest? So the sum of the forces in the x direction equals 0. Okay, so that's our problem. Well, this problem is actually a lot simpler than it appears. We look at the different forces. So F1, you're pushing on a handle. Part of your force is pushing in the x direction, and part of it's pushing in the y direction. But in this case, we only care about the x-axis forces. So the force here, Fx, for this force would be equal to F1 times the cosine of the angle. So Fx here is equal to 5.5 newtons times the cosine of 30 degrees. We'll get a number for that in a bit. Well, you'll get a number for it. And then the second force that comes into play is this one. And now we're pulling, and part of that pulling is causing it to go forward. And so that also has an Fx. And that Fx will be equal to the force that's applied, in this case force 2, times the cosine of the angle. So this Fx will be equal to F2, which is 3.5 newtons, times the cosine of 37 degrees. And again, that will turn into a number, and you'll be able to calculate that number yourself. So the final question says, what third force would you need to keep it from moving? And as it turns out, this is eventually going to be a frictional force. It's going to be some kind of force. Nail the block to the ground. Something is going to keep it from moving. And the third force is going to have to be in the opposite direction of these two. And the third force, force 3, is going to be entirely in the x direction. So it doesn't have a component. We're simply asked what force horizontally would keep it from moving. Friction, for instance. And it's going to have to be equal to this Fx, which is going to be 5.5 newtons times the cosine of 30, plus this Fx, which is going to be 3.5 newtons times the cosine of 37. And then, because it's going to be in the opposite direction, it's going to be negative. So whatever that adds up to be, throw a negative on it, and that's the correct answer. So that when you add this force in the x-axis, plus this force in the x-axis, plus this force in the x-axis, the sum of the forces in the x-axis equals 0, which means it doesn't move horizontally. And that was the question. Thanks a lot.